the introduction of binomial. So we are still talking about factorial. And we've seen one or two definitions there. The important one that we picked was that we could write n factorial as n minus 1, n minus 2, n minus 3, going down all the way up to n minus n. For long as when n we put a factorial, and that there's no harm in writing it as n minus 1 factorial, and that there's no harm in writing it as, if we wanted, suppose it was n plus 1 factorial, then we would have said, oh, this is just n plus 1, and then n plus 1 minus 1. Front end here is a factorial, meaning this will be like n plus 1, and then 1 minus 1, that is 0. So we just get n factorial there. Well, what if it was r? There's no difference. It's still r. If you want to say r minus 1 factorial. And what if it's r plus 1? There's no difference. You can still do the same. R plus 1. The next one, we subtract the 1, it will become r factorial. So here it can be anything. There's no problem. Okay? And we also define that n to r is simply expressed as n factorial over r factorial, and then n minus r factorial, like that. That is how we define it. Well, let's see a bit of some examples of how we can go around these things. So I'm now going to throw it and pick question 2. I've picked question 2 there. Let n be positive. Okay. Let n be positive. Then so for n. So for n, the first one, n choose 2 is equal to 15. So what do we know about n choose 2? By definition, it's n factorial over 2 factorial n minus 2 factorial. At this moment, the right hand side is 215. Wow, are we able to write n factorial? Well, let's pick this form of n factorial. But we'll do n and do n minus 1 and do n minus 2. So n here, and then 2 factorial is just the same thing as 2, and then n minus 2 factorial is equal to 15. So this and this can go. Then we'll have n minus 1 over 2 is equal to 15. If we cross multiply, we'll get n minus 1 is equal to 30. When you multiply 2 times 15. Like that. The simplest way of solving this question is to rewrite 30. You write 30 as 6 times 5. So that you see that, oh, actually this is like n is equal to 6. Direct. If I write that one, then I get, because it means that this guy was, you had 4 factorial on the other side and the other side, but then they divided it, so it went. So n should be 6. If I can't see it in this way, then what do? I pick it from here, expand. N squared minus n is equal to 30. Rewrite it. N squared minus n minus 30 is equal to 0. So the product is negative 30 and the sum is negative 1. So you can use negative 6 and positive 5. Which is n minus 6 plus 5, n minus 6, 0. Common, n minus 6, n plus 5. So we get n is equal to 6 or n is equal to negative 5. But the question says let n be positive. Therefore, n is equal to 6 is the only positive that we're able to see here.
Sir,
Mhm.
what are the requirements for picking 6 and 5, for multiplying 6 and 5 to find the value of n? What method did you use?
Now, I just saw that this 30 is a product of two numbers, 6 and 5. And I picked 6 and 5. I know there's 10 and 3, but I picked 6 and 5 because it looks like since the left was n and then n minus 1, the right also is 6 and then 6 minus 1. So you get that? That's why I said,
Yeah,
then it means n is equal to 6.
okay.
Oh, but if somebody can't see that, then you go the quadratic one. Then just don't submit both solutions because you are told n must be positive. So you restrict yourself there. Good people. How is it? Agatha, you want to say something? Or we go our picture. That is so. Is it making sense now? I want you to respond, guys, so that see how we progress. Okay, let's move. When you're uncomfortable, I think you're going to raise issues. The next question, with a clear understanding of the factorial. Let's see if we're able to answer B. N plus 2, choose 4, being equal to 6, and then n choose 2. Oh, here we use the definition again. So on the left, you have n plus 2 factorial over 4 factorial n plus 2 minus 4 factorial is equal to 6 here. And then we expand, that is n factorial over 2 factorial and n minus 2 factorial, like that. Then what next? So we have n plus 2 factorial on top there over, we want to fix the 4 factorial, and then inside here we get 2 minus 4, that is n minus 2 factorial. So that we get 6 n factorial over 2 factorial n minus 2 factorial. But these are equations, so cross multiply. We'll have 2 factorial, which is just 2, n plus 2 factorial, n minus 2 factorial is equal to 6 n factorial multiplied by 4 factorial and n minus 2 factorial. So here we're just cross multiplying. Then we see that this and this will cancel by division. What have I done? I've divided by n minus 2 factorial and divided by n minus 2 factorial. So it has gone by division. Then we've remained with, or maybe we should also divide, what else? Maybe we should also divide the 2 so that it goes here and here the 2, so that the 2 reduces this guy to 3. So that now we have n plus 2 factorial is equal to 4 factorial, which is 4.
Sir,
Hello.
where did you get this denominator from?
That is line number, arrow number 4. Arrow
Yes.
number 3.
Number 4. No, number 4. No, that's
1, 2, 3. Number 3. Here. This one.
yes, sir.
So here we are saying, since we cross multiplied, this one came this side and this one went that side. We had this and this, but we have seen common things. We've seen n minus 2 factorial and n minus 2 factorial here. We've seen 2 and we've seen 6. So if we divide by 2n minus 2 factorial by 2, so these will cancel and those will cancel. Then what remains? We'll have n plus 2 factorial here. And then that side we'll have 4 factorial multiplied by 3 n factorial. Like that. Then we can now temper with the n plus 2. We'll write it as n plus 2, n plus 1, and then n factorial. What have we done? We know it's n plus 2, and then n plus 2 minus 1, and then n plus 2 minus 2. We want to end here. This is n plus 2, n plus 1, and then n factorial. So this is where we got this one from. Okay. So let's see what happens. This thing is equal to, oh, there's an equal sign here. It's equal to 4 factorial multiplied by 3n factorial. So again, we can divide by n factorial. We can divide by n factorial. But this and this and that. Then we'll have n plus 2. Then we'll have n plus 1 is equal to, what is 4 factorial? 4 factorial. It's 4 by 3 by 2. So this is, and then, so this is like 24. So we have 24 here. And then by these 3, we get what do we get? We get 4, scale 1, 6, 7. So we get 72. Then we do our usual thing. So we do n plus 2, n plus 1, and look for two numbers that when you multiply, they will give us 72, like 8 and 7. 9 and 8. Yes. So this is 9 by 8. We'll get 9 by 8, we get 72. This means that n plus 2 is equal to 9. So that n is equal to 9 minus 2. So n is equal to 7. Even if you pick this one, do the same thing. You said n plus 1 is equal to 8. It will be n is equal to 8 minus 1, which is 7. What are the consequences of not seeing it like that? If you don't see it like that, then look what happens. It becomes a polynomial because you have n squared. Oh, it becomes a quadratic n squared plus n plus 2n plus 2 minus 72 is equal to 0. So that you get n squared plus 3n minus 70 is equal to 0. Then look for factors. Factors like 10 and 7. So you have n squared minus 7n plus 10n minus 70 is 0. When you say n minus 7 plus 10n minus 7 is 0. So we have n minus 7, n plus 10 is 0. So n is 7 or n is negative 10. But in the question they have said, they want a positive n. Therefore, n is equal to 7. That's how nice it is. Oh, we extend a bit. We look at the proof on question 3, since we look like we enjoyed the application of it. Question 3, we have to prove that any error. Remember we use this thing. Now we need to show that it's true the way we applied it. N plus 1 and error. So we'll pick the left-hand side, is the one that we are able to differentiate here. It is n error. We haven't done partial fractions. Don't worry, it's like a small topic. So we have n factorial over r factorial, n minus r factorial, plus n factorial over r minus 1 factorial, and then n minus r minus 1 factorial. By definition, we're just placing here in the definition. Maybe we can retouch it a bit. So we have n factorial, r factorial, n minus r factorial plus n factorial over r minus 1 factorial. So we came to do this. This is n minus r minus 1. We can expand it to n minus r plus 1 and write it as n plus 1 minus r. So n plus 1 minus r factorial. Okay. So now these are fractions. Every time you're faced with fractions, you know, the first thing to think about is the common denominator. So what is the biggest number here and the factor for the other between r factorial and r minus 1? Oh, if you remember very well, we said we could write r factorial as r multiplied by r minus 1 factorial. So it means r factorial can be written in this form. So maybe we'll use that form of r factorial, and then we would have answered the question of which one is the common denominator between r factorial and this one. That should mean the same thing between this guy and this one, because we can write n plus 1 minus r factorial as n plus 1 minus r multiplied by n minus r factorial. So you can see that we write it in that form, n plus 1 minus r multiplied by n minus r factorial. Then we'll see that there's actually nothing much here. When you divide this guy, when you divide r factorial in this, we get 1, and then this one in this, we get this piece here. So we get n plus 1 minus r, and then multiplied by n factorial plus this one is this whole thing. So there will remain with r multiplied by n factorial. Because you see, r minus 1 will take away its form. So for the second one, we are saying this one will take away this one. And then this is this here, which is this, which is the whole thing down here. Also remains with r. Okay. And then what is common on top? We've seen that r factorial is common on top. So then we'll have n plus 1 minus r plus r over, well, this we can write it in its r form. So say r factorial, and this one also in this form, so that we have n plus 1 minus r factorial. Then we see that here we just have n factorial multiplied by n plus 1 over r factorial n plus 1 minus r factorial. We can write, look, this is like n plus 1. If you have n factorial, you write it as n plus 1 multiplied by n factorial, which is what we have in the numerator here. Oh, yes. Awesome. So what you're doing is, here we just have to write this r factorial in its form of this one. Like that. And also this one, we used it in that form. So we could bring it down here in the denominator. And then push it back. This one came from this part now. errors can confuse you. I don't worry about the errors.
Sir,
Hello.
I have a question. What if you can't think the way you've thought here? Is there any other way you can prove this? Or we just have to think like this?
Okay, maybe there could be other ways, but not the one for putting numbers. Not the one for putting numbers. I've never thought
Because
about
this looks
another.
complicated.
No, but this is not complicated. This should be the easiest because we're just going to the denominator. I think where it gets complicated is just on this line, how you come up with a common denominator. But you haven't done anything complicated. You just multiplied this multiplied by this one to form the common denominator.
Just there, sir, maybe explain some more.
Because here, look, we are saying what is R factorial? R factorial can be written as R multiplied by R minus 1 factorial. Okay? Meaning that any factorial, you can write it as that thing itself multiplied by, you subtract a 1. Like n plus 1 minus R. When you subtract a 1 here, it becomes n minus R just because the plus 1 goes when you bring a minus 1. This is what we had on the first page here. So if we have n plus 1, you can write as n plus 1 multiplied by n plus 1 minus 1. What is n plus 1 minus 1? It's just n factorial. What is R factorial? It is R multiplied by R minus 1 factorial. And then you have a common denominator to pick. Now you're faced with a situation which has R factorial and R minus 1 factorial. Which one is bigger between these two? So we're saying R factorial is bigger because we can write it as R times R minus 1 factorial. But when picking it as a common denominator, we've picked it in this way so that we're able to see when we come to divide by this one, that it will only cancel the R minus 1 factorial. The R part will remain. And that this one will only cancel this part. When it comes here, this part will remain. So now we start dividing. What is this whole thing into this one? You've seen that this first part here is what we have called R factorial. So it is just R factorial, this whole part. So this in there they cancel. Then you remain with this as this one. So this one will take away this part. And this will remain. Then this times the numerator for that one, you get this. You get this one. Plus this whole thing here, which is defined here as this. When you divide this into this one, it will cancel because these are equal. Then you have now R minus 1 factorial, R minus 1 factorial. So these will cancel. So we only remain with R. So we've multiplied the numerator here by R. Then what's common? We have n factorial and we have n factorial. So you factor it out for you to get n plus 1 minus R, this one, plus the remaining thing here, R. Then divide by, we now write this in its original form as R factorial. Yeah. And this in its original form as n plus 1 minus R factorial. This. Then we see that minus R plus R is just 0, so we have n plus 1 here. Simple. Then we have R factorial, n plus 1 minus R. And this thing. Now we're saying this thing here, it is what we defined there as n plus 1 minus, as n plus 1 factorial, which is n plus 1 multiplied by n factorial. So we can write it as n plus 1 factorial over the down part, we copy the way it is. And if you remember very well, this is the definition of n plus 1, choose R. Because you say the numerator factorial over the denominator multiplied by the numerator minus the denominator. And this is what you have on the right hand side. Like that. So we have so much to understand. Maybe on this page, if you can take your time, go through again, Then on Wednesday,
Oh, sir, just a question. How is the denominator turning into R?
oh, why this setup? That's the question. If you have n plus 1, choose R. How do we define it? We say n plus 1 factorial over R factorial, this one, then this minus this, which is what we have here.
For an exam.
So try to understand. I got a request that we should move a bit faster, especially after the quiz. But because your exams are, some of you, the exams are starting the same week the exams are starting on main campus and the like. So maybe you may need time to digest these things and an update. So we'll move as fast as possible. I think the last date of learning here, maybe 15 October, so would have finished our coverage. And it's not just finishing, but would have also revised intensively preparation for the exam, so that you have time to go through. So you can go through and get on. Have a good night.